Self-explanatory. Radical function. It's a function with a radical in it. It's exactly what it is. So here we go. Let's scroll on down a little bit. Parent functions for square root and cube roots. Basically, these are more parent functions for even roots and odd roots. Okay, so like an even root, this is f of x is the square root of x. Okay, because I can't take a square root or a fourth root of a negative number. Yes, sir. The red one on the desk somewhere. It's there. But you can't take the square root of a negative number. That's why there's nothing to the left. Or the fourth root of a negative, or an eighth root. In any even numbered root, you can't take a negative. You can't do a negative, or otherwise it becomes imaginary. Okay? And the domain and the range is all based upon that endpoint right there. That endpoint. Your domain is your x's, so it starts at the endpoint, which your x value right there is 0. Is it going to the right or to the left? To the right. So your domain is either x is greater than or equal to 0, or it's from 0 to infinity. It's bigger than 0, or hey, it's from 0 to infinity, however you want to write that. All right? The same thing with your range. It's all based around your endpoint. In this case, your endpoint is at your y is 0. And is it going up or down? Up. The graph goes up. So y is greater than or equal to 0 because your range is y values. Or it's from 0 to infinity. Cool? So your even root functions are going to have a domain and range based around the endpoint. Basically, find the endpoint and know which way it's going from there. Cool? The parent functions for I want to call these odd roots. They do a square and a cube. I just say odd and even, but so these are third roots, fifth roots, seventh roots, ninth roots. In this case, this is f of x equals the third root of x. And it can go to the left because I can take the odd root of a negative, okay? I can take the root of -9, third root of -9, stuff like that. So it goes left forever, it goes right forever. What do we call it when it goes left forever and right forever? Infinity to negative infinity to positive infinity. Another word for that is? Starts with an all. All real numbers. All right, so your domain and range, in this case, they are all real numbers. Or you could write negative infinity to positive infinity, however you want to write that. And that is the same with your range. All right, it goes down forever. I know it's kind of slanted, but it keeps on going down. And it goes up forever. It's kind of slanted, but it keeps on going up. So any x or y is available for your odd numbered functions. Okay, there is no limitations on it. Cool? Any questions on this? All right, here we go. Let's turn the page. Transformations. Okay, if you don't get transformations by now, either A, we need to have a one-on-one tutoring session, or B, it's time to start learning them. One or the other. You just either truly don't get it or you haven't tried. One or the other. And that's okay. No, it's not both. It's one of them, not the other. Anyways, so real fast. All right, what we call, remember how we say inside and outside the parentheses? Inside the parentheses is backwards, outside the parentheses is normal. Well, anything under the radical, that is inside. Okay? Anything under the radical, that's inside. So basically, f of x plus or minus h, well, that's a shift left or right. Okay, f of x, if it's outside plus or minus k, well, that's a shift up or down. Okay. Your reflections, well, if I have a negative on the outside versus a negative on the inside. Well, if it's on the outside, it reflects across x. And if it's on the inside, it's across y. All right, stretches and shrinks. If I'm multiplying by something on the inside, well, that's horizontal and it's backwards. So if b is bigger than 1, your absolute value of b is bigger than 1. That basically means anything 1 or bigger, as well as like your negative side too. So like -8, the absolute value of that's bigger than 1. that is a shrink. The absolute value of b, if it's less than 1, that is a stretch. All right? And then last but not least, your a of f of x. If you're multiplying on the outside, well, if it's bigger than 1, it's a stretch. Just like you would think so. If it's less than 1, it's a shrink. Okay, that I don't feel like filling the whole thing out. I don't think we need to. If you need more information than that, feel free to consult your Chapter 5 notes. It's identical. Or go to the book under 6.3. It's going to have this exact chart, if that's what you need. Okay? I don't mean that as a slam. I just mean that's just what it is. Cool? All right, I got a couple people still writing. I'll wait a moment. Let's keep rolling. Graph each function and its parent function. I'm not going to graph the parent. I'm just going to graph the function. And then identify the domain and range. Okay, so to graph these, the most important piece is that endpoint. Well, the endpoint is at your HK. It's whatever is added on the inside or outside. So for letter A, is there anything added underneath the radical, underneath that bar right there? Anything added or subtracted? So we would put a 0. Is there anything added or subtracted on the outside? No. So your y value is also 0. That's your endpoint. Cool? That's your endpoint. Unless it shifts it around, which actually, do any of them on this page, A, B, C, or D, shift the endpoint around at all? No, none of them have a plus or minus in there anyway. So that's what you got. All right, here we go. Turn your calculator on. Not pass control, remote desktop. Here we go. Y equals. Nope. Clear, clear. We've got the square root, which I'm just going to go, we can do the square root like this. The square root of 1/4 x. Now, I do this because you can always put in fractions like this. Just put it in parentheses. Or make it a decimal, 0.25. Now, don't do a 1/3 as a decimal. If it's repeating, you have to put it in as a fraction. Okay? But if you know the decimal, just stick the decimal. That's fine. All right, so from here, if you want to graph it, that's fine. This is what it looks like. Yay! But that's not what I care about. What I care about is this. Cool? What I care about is the table. Why are they errors?
Because they're errors.
Can you take the square root of a negative? No. No! Because if I stick that in there, the equation poops itself, says, I don't know what to do! So it spits out an error. And that's okay. It's what it's supposed to do. All right, so we got an endpoint at 0, 0. We got a point at 4, 1. And I'm just going to grab the whole number of points. Now, this one's a bit of an exception because those are the only two ones that fit on the graph, right? 0, 0, and 4, 1. So, like, these are all ugly decimals except for this one right here.
And 1.
All right, and the 1.5. So I'm going to grab those ones as well just so I have a little bit more to anchor to other than, like, 1 point. But like these are ugly decimals, I'm not going to deal with them. So here we go. Let's go back to the chart. Go back to my equation. So I had 1 at 0.5. I had, what was it, 4 at 1 and 9 at 1.5? Is that what it was? Or was it 8 at 1.5?
9.
It was at 9? Okay. So there's your points. Great. 0, 0, 1.5, 4, 1. 9, 1.5, and there you go.
What was the second one?
4, 1. And there's your graph. Cool?
That's 1.
9, 1.5. And that's your graph. Easy peasy, chicken greasy. Cool? Now it asks for the domain and range, and the domain and range for these ones has all to do with the endpoint. Okay, so for your domain, let's do it in green. So domain, is that x's or y's? X. Okay, so what's the x value at your endpoint? 0. Does it go to the right or the left? To the right. So it's from 0 to infinity. Because I want you to think we're just looking at the x values. We're not looking at the y's at all in this case. So horizontally, it is going to the right. That's why I put it that way. That's okay, question. Your range, okay, where is the endpoint for the range? Where's the endpoint for the range? Your y value?
0.
0. And which way does it go, up or down?
Up.
Up. All right, so it's also from 0 to infinity. They happen to be the same, but they won't always. Okay? I'll go ahead and erase those. And that's what it asked you for. Cool? Any questions, comments, concerns, public service announcements, limericks, bad jokes, dirty jokes? No dirty jokes. Bad jokes are fine. Not right now. Okay. All right, so letter B. You can see why I had to turn off the recording. All right, letter B. So here we go. We've got this guy. Great. So where would the end point in this one be? Where would or actually in this case, an inflection point. But what is being added on the inside?
X.
Anything being added? No pluses or minuses, so again 0. What about on the outside?
-3.
Is there anything added? No, so it's also 0. This -3 is not added, it is actually what? It's multiplied.
Multiplied.
Because it's 3 times all that. It just happens to be a negative number.
So to be subtracting or adding, how have to be?
It either has to be like -3 plus all of that, or plus out back. You follow me like that? Or plus or minus. But that's what you're looking for. What is being added or subtracted on the outside? All right, so in this case, it's an inflection point, and I'll tell you why it's different in a minute. But here we go. Let's go over to our graph. Let's go over to calculator. We got error. No, actually, there are no errors on this one.
Well, they are.
There shouldn't be. So we've got, because you typed it in wrong, -3 square root. It's not a square root, though. It is a cube root of x to the... How do you put a cube root as a fraction? As an exponent? That's how you do it. Now, I'll say this. There is a button in the calculator that will allow you to do this with a 4th and a 5th and a 6th and a 7th. If you find it, great. I'm not going to show you where it is, because knowing how to do it this way will serve your purposes a lot longer. Like digging that in your brain will help you out long term than knowing where the button is on the calculator. You follow me on that? All right, so there's that. And if I were to graph it, it looks like this. Oh, did I type it in? No, I typed it in right. That's right. But cool. I just want the whole numbered points. So second table. I've got 8, -6. I've got 1, -3. I have 0, 0.
-1 and 3.
Good. -1 and 3 is 1. Hey, there's one more up there. I think there's -8 and 6. Yep, -8 and 6. So here we go. Let's.
Do you put the negatives too?
Yep, I would put them all up there because the graph goes to the left. So we got -8 and 6. We got is it 1 and 3?
Yeah.
Yeah, +1 and -3 and +8 and -6. Those are our points. Okay, and so we got 1, 2, 3, 4, 5, 6. 1, 2, 3. 0, 3. Yeah, right there. And you go like, oh, that's horrible. Let's try that again. And it looks like that. All right. Now again, does this graph have an actual end point?
No.
No, it doesn't have a place where it stops, right? But that 0, 0 right here, we still dealt with that, right? You're right. The domain range is all real numbers. We'll talk about that in a second. You're absolutely right. But this, what we thought was the end point, is actually an inflection point. The reason it's called that is this is curving upwards, right?
Yeah.
And if you were to continue that pattern, it looks like it would keep going like that, right?
Problem.
Kind of like in a big parabola. Well, instead, it stops and it starts going the other way. That's why it's called an inflection point. It's going up and then it goes, hey, I'm not going to go that way. I'm going to go that way instead. So it's just called an inflection point, but we find it the exact same way. It's what is being added or subtracted, inside or outside. And Daniel, you're absolutely right. What would be the domain and the range for this function? All real numbers, so negative infinity to positive infinity, or that double-backed r, however you want to say it. Cool? Any questions about this at all? Anything you want to talk about?
The child okay.
Is the child okay? There was no child. It's just a story. Although it'd be really funny if it actually happened.
What's your favorite TV show?
What's my favorite TV show? I don't know. Right now I'm watching Bull. Anyways. All right, here we go. Turn the page. Turn the page. We're going to do one of these real quick, and then we'll turn the page again. Describe the transformations of the parent functions. Again, transformations I think you should be able to do. But here we go. If I'm subtracting 3 on the inside, what is it doing? It's shifting, right? Which way? Up, down, left, or right? Right. There we go. Everything inside's backwards. All right. If we're adding 4 on the outside, what's it doing? Shifting up. Exactly. Okay. So the transformations are the same. You just got to know, hey, what's inside, what's outside. All right. So once you find those out, you know, oh well, that means my inflection, my endpoint, instead of 0, 0. What's your x coordinate going to be for it? Close, but it didn't go left 3, it went right 3. So instead of 0, it's going to be 3, and instead of 0, it's going to be 4, because it went right 3 and up 4. Cool. So that's your endpoint.
So you just switch to a positive and then put the number that's outside the square root.
Yep. Remember, everything inside the parentheses is backwards. That's exactly what this is. Anything underneath the radical, anything underneath that umbrella is backwards. All right. Let's go back to your calculators. Remote. So we got y equals.
0 is error.
So this, what is it? X minus 3 to the 0.5 plus 4. Now, okay, here's the deal. No, you don't have to raise it to the 0.5 like this. I'm just showing you there's multiple ways of doing it. Okay, I could have put a 1/2 up there. I could have actually used the square root button. Okay, I'm just showing you there's more than one way to skin a Kia. All right, here we go. The table. All right, error. Keep going down, keep going down, keep going down. Yeah, there it goes. 4, 5, and what? 7, 6. Sweet. These are your points right here. What did I just do? These are your points. 7, 6. Yeah. I don't know what I said. Yeah, but we don't go up to 12 on our sheet.
19 and 8.
Sweet, but there's not a 19 on your graph. But you're right. You're absolutely right. So here we go. 4, 5, and 7, 6. Let's go back. 4, 5, and 7, 6. So 1, 2, 3, 4. 4. Nope, that's 3, 3. 4, 5, 7. That's 7, 6. There it is. There you go. And it goes like this. Like that. And if you don't make the sound effects, you did it wrong. Cool? So there's your graph. All right. Domain and range. Okay, domain and range. Your domain, is that x values or y values? X. So find the x. What's the x value at your endpoint? 3, right there. Which way does it go? Right. So that's either x is greater than or equal to 3, or you can say it's from 3 to infinity. I don't care which way you go. Cool. That's all right.
How do you get the 3 to infinity?
How did I get to 3? Where is your endpoint? A domain is x values. So where is the x value right here?
So you use the x value
For your domain, yeah. Domain is nothing but x's. That's why I go left and right, because that's your x bar. All right, I kind of use that as my kind of like a number line. Your range. I want to change the color to blue. I haven't used blue in a while.
4 to infinity.
Good. It is from 4 to infinity because that's your y value right there, and it goes up. So y is greater than or equal to 4, or 4 to infinity, however you want to think about that. Cool?
No.
In all seriousness, yes or no? Is that a no?
Yeah.
Okay. What's up, Maria?
I don't know, why do you keep the bracket in
Good point. Because brackets and parentheses. If I do like this, from -4 to 4, that means I actually have points there. But if I have like parentheses -4 to 4 with a bracket, that means the -4 doesn't actually exist. It's more of a boundary. Does that make sense?
Sure.
That's why. But good question.
You don't know which one.
Yeah. All right, turn the page. Let's keep rolling. Is that the one I want to talk about? No, well, this is just more transformation muck. All right, just turn it back into an equation. Turn the page one more time and we'll call it quits. Yes! These are sideways parabolas.
Oh no.
And something you've seen before, but probably never like this. All right, so first things first. Use technology to graph these things. So, letter A. Can you put a y squared into your y equals? No. So you have to solve for it, okay? So we'll start here. If I were to solve for this, what would be the first thing you do? Okay, let's stop. We got a lot of things going on. Are we talking about the exponent, or are we talking about the 1/2? Ooh.
1/2.
The 1/2. All right, we're doing PEMDAS backwards. So your exponents you got to deal with second. So how do I move a multiply by 1/2 to the other side? You can multiply by 2, because that's really a divide by 2, right? So I'll multiply the right side by 2. So that's y squared equals 2x. Cool? Huh? No, the exponents will do that second. Start off, it's kind of, never mind. It's your PEMDAS backwards, PEMDAS. So adding and subtracting, then the multiplying, then the exponents. Yeah, I know. What are you going to do? Oh, all right, what's next? Now you can square root it. To get rid of that y squared, I mean. So we got y squared, not y squared, y equals almost. What are we missing? Plus or minus, very good. Don't worry, we've forgotten it every single period today. All right? When you are taking an even root to get rid of the exponent, there's a plus or minus there. Odd roots? No. Even roots? Yes. So, we actually have to put this in our calculator twice. Once for the positive, once for the negative. So, here we go. Y equals. Clear. We got 2x to the 1/2. And we've got negative parentheses 2x. And I'm just going to put it to the 0.5 to reiterate the idea that you could do either. It does not matter. They mean the same thing. All right, and if I graph it, yep, there's the top one, there's the bottom one. It's a sideways parabola. Exactly what it is. All right. So second table. So I'll go up to, we got 8 at 4 and -4, 2 at 2 and -2, and when x is 0, well, both of them are 0. So I really have 5 points here. All right, these are the same, but this one, when x is 2, it can be 2, and x is 2, it can be -2. Same here, I got 8, 4, and 8, -4. All right, so there are 5 points there. Here we go. So my table.
We're gonna have 2 tables.
I got 0, 0. I've got 2, 2. I got 2, -2. I got 8, 4, and 8, -4. Cool. Still good with that? And so let's plot that sucker. We got 0, 0. We got 2 up and down here. I'll zoom back out in just a second. And 8 at 4 and negative 4, and it goes like this. And again, sound effects are absolutely mandatory. Mandatory. Yeah, whatever. What are you going to do? All right. Any questions on how we did that at all? All right, domain and range. Same idea. Domain. Domain is x values. What is the furthest point to the left, x-wise? 0. Okay, does it go to the right or the left? To the right. So 0 to infinity. Or x is greater than or equal to 0. Your range is actually going to be a little different this time. How far down does this graph go? It goes on forever, right? It keeps going down forever. Does it go up forever? Yeah. What do we call that? Yep, or negative infinity to positive infinity, however you want to say that. So your range is negative infinity to positive infinity, or it's all real numbers. Either way. Cool. I told you today was a pretty easy day. We just kind of got to cover it. Follow?
Are you gonna try broken?
No, we're not going to. I mean, if you want to, we can. Here we go. Letter B. Last one, and I'll call it quits. Letter B. Letter B, letter B, letter B, letter B. Anybody actually know what kind of equation this is? What kind of graph this is?
It's a dot graph.
No, it's not a dot. That's okay. Let's solve for y.
Is it linear?
It is not linear.
Quadratic.
It is not quadratic. But let's keep going. I'll give you a hint. Read the instructions.
Parabola.
Did we just graph a parabola?
Technology graph.
Circle.
It's a circle. That is actually the equation for a circle with a radius of 4 units. It really is. All right, so here we go. Let's start off. Let's solve for y. So start off, subtract the x squared. So I got y squared equals 16 minus x squared. Okay, to get rid of the y squared, what do we got to do? We got to square root it. So we got y equals plus or minus the square root of 16 minus x squared. Cool?
Is it a slide? No. Wait.
Isn't it what? No, okay. So again, you got to put it in twice. Once for the positive side, that's the top half of it. Once for the negative side, that's for the bottom half of it. And here we go. I'll do it too. Y equals, clear, parentheses, 16
Maria
minus...
had a good question.
What's up, Maria?
She wanted to know if the 16 simplifies to 4.
If there was not a minus between them, you could pull it out. But because it's a binomial, not a single term, you can't. But that is an excellent question.
I mean, I kind of want to. She asked.
Well, you said Maria, so it could have been either. Maybe you were talking about yourself in the third person. She's like, yeah, I'm that kind of person. So we graph it, and it looks like this.
But that circle.
Well, it's an oval because it's not square. Hit the zoom button, and scroll down to square.
Oh, okay. See, yeah, it looks like a circle.
If you zoom square, it makes it even up and down, left and right. All right, the one thing I will say about this is you notice how these little gaps here between the two?
Yeah.
I have never seen a reasonable explanation as to why that is there. That's what it does. Just accept it and move on with life. All right? If you don't want to accept it, then you know what? You will be stuck here in limbo for the rest of your life. You are stuck in my class for the rest of your natural life. I know, send me to hell now, right? All right, so here we go. Let's get your points. Second table. La 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 la. Tra la la.
Error. I didn't get it.
Error.
0.
Yeah, there's errors on both sides, but you got -4 and 0. You got 0 above and below,
4-0.
and the 4 at the 0. So you got 1 point here, 2 points there, and 1 point there. Cool? Did you say no? Oh, okay. It's fine if you said no. I'm just... So when x is negative 4, they were both 0. When x is 0, you got 4 and negative 4. And when x is negative 4, you also had 0. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And you get something that looks... And that is the best drawn circle you've ever seen in your life.
Perfection at its finest.
Don't say otherwise if you want to pass the class. All right, here we go.
Say that again.
Nothing. I know, isn't it? Yes.
Who's your master?
Who's my master? All right. All right, so there's your circle. Last but not least, domain and range. Your domain. Least x to greatest x. What is the furthest x on the left, the most negative? Negative 4, that's the furthest point on the left. What's the furthest point on the right? Positive 4. And since they're actually part of the graph, they get the brackets. They get the braces. Honestly, as an inequality, you could also do it like this. Less than or equal to x, less than or equal to 4. All right, your range. Okay, bottom to top. What is the lowest point?
Negative 4.
What's the highest point?
4. Positive 4.
Positive 4. So again, negative 4 to 4. Or you could say negative 4 less than or equal to y, less than or equal to 4. It's been a while since we've seen the compound ones, but that's what it is. Cool? Done.